Today, I want to discuss about this cheat sheet provided by these two twin professors from MIT 7 years ago, but it's still very valuable to this day. And I want to go fast through each concept and let everyone understand can they get started within this deep learning. Deep learning is just a way of teaching computers by example. Instead of writing rules by hand, we show data and the model learns patterns. Let me zoom in a bit. Okay, I can do this. Give me 1 second. Perfect. At its core, deep learning uses neural nets. This is the architecture of it, which are inspired by the human brain, but much simpler. Neural nets is the core building block, just layers of numbers connected together. Each neuron does 3 things: takes inputs, multiplies them by weights, and adds a bias. As you can see in the formula down below, weights W, B, and Z are the weights, bias, and output. This formula looks scary, but it just means weights multiplied by inputs plus bias. Activation functions, on the other hand, is the reason why networks can learn. If we didn't use activation function, neural nets would be useless. Activation functions decide how much signal passes through a neuron. Simply said, sigmoid is that activation function that squashes output between 0 and 1, as we can see in this graph. It's used mostly for probabilities. Then we have 10, which is similar but centered around 0, and ReLU is fast, simple, and used almost everywhere today. Output 0 or keeps the value. Regarding loss functions, this is how the model knows it's wrong. A model learns by making mistakes, but first it needs to measure them. A loss function tells the model how wrong it is. Cross entropy is mentioned here. If the model is confident and wrong, it gets a big penalty. If it's confident and right, a smaller penalty. Training is just trying to make the loss smaller and smaller. That's the main objective of it. What we have next, there is a backpropagation, and backpropagation is how the model fixes itself. The error goes backward through the network and updates each weight. If the final answer is wrong, the model asks which weights caused this mistake, then it slightly adjusts them. This uses calculus, but you don't need to do it by hand. I missed optimization, which is how we update the weights. Once we know how wrong we are, we need to update it. Gradient descent just means take a smaller step in the direction that reduces error. Learning rate, on this other hand, is when it gets too big, model jumps around. If the learning rate is too small, model learns very slowly. That's why we are trying to adjust all of these. Okay, we went through everything here. And now moving on to convolutional neural networks. For images, we don't use normal neural networks. CNNs slide small filters over images to detect patterns. Simpler said, if we have early layers, those are edges, middle layers are shapes, and deeper layers are objects. Good. Batch normalization. Batch normalization keeps values in a healthy range. This makes training faster and more stable. Almost every modern deep network uses it. We got recurrent neural networks for sequences are used when order matters. That's if we refer to text, audio, time series. They remember past information using a hidden state. Problem with classic RNNs is that they forget long-term information. And then we have LSTM, which fixes that problem we were discussing about before, the memory one. But it basically explains gates simply. For get gate, what to erase, input gate, what to save, output gate, what to show. This lets the model remember important things for longer. And reinforcement learning and control, which is the most used in bigger LLMs we see today is learning by trial and error. Reinforcement learning is different than what we have seen so far. There are no correct answers, only rewards. A loop would look like this. Agent sees a state, takes action, gets reward, learns. And this is how game playing AIs work. This cheat sheet is great because it shows how everything connects. If you understand this page, you understand the foundation of deep learning. You don't need to memorize formulas, just understand the flow. That's the first step, and then keep trying it out. Vibe code a lot, work on applications, ask the right questions. But that was my introduction of it. Let me know if you enjoyed it in the comments and if you want me to continue this series. Thank you.